Hi everyone, welcome back to Advanced Functions, MHF4U 1. In this lesson, we are going to take a look at the properties of graphs of functions. So our learning goals today are to identify intervals of increase or decrease, identify odd or even functions, and take a look at the end behavior of a graph. So some of the properties that we know so far from grade 11 and from previous class is domain and range. Domain is a set of x values, and range is a set of y values. X-intercept happens when y is equal to 0. So for example, we have a x-intercept over here. And y-intercept happens when x is equal to 0. In this case, we have a y-intercept over here. Maximum and minimum points. So maximum minimum points are vertex points. So in this case, the maximum point is when f at a is greater than f at x. So your a is the vertex, the x value. And minimum point is when the vertex is at the bottom and the graph is going upward. So your minimum point f at a is less than f at x. Vertical and horizontal asymptote. Remember, asymptote is a line, a graph that touches, it will never touch, but it will approach very, very closely. So for example, vertical line always starts with x is equal to a number. And horizontal asymptote is when y is equal to a number. So keep in mind, for example, we have a graph that looks like this. And we have a vertical asymptote at x is equal to, let's say, -3. It's going to keep going down, but it will never touch at -3, but only approach. Axis of symmetry is where the graph is symmetrical. So the equation of axis of symmetry is x is equal to a number. So representation of an axis of symmetry is when you have like a parabola. Okay, so in this case, the axis of symmetry happens right in the middle over here when x is equal to 0. Now, interval of increase or decrease. So interval is I'm specifically looking at the domain of x. So first step is you need to identify a turning point. A turning point is a point where the function, the slope changes from increasing or decreasing or vice versa. So for example, we have a parabola. The turning point is over here, the vertex. So the graph is decreasing, and at that turning point, the tangent or the graph, the slope, it increases. After you identify the turning point, we're going to see, is the slope positive? If it's positive, the interval of increase. If the slope is negative, it's going to be an interval of decrease. So we're always looking at what's happening to the y value, but this interval is always stated in the domain, x. Let's do an example. Find intervals of increase and decrease. First step, let's identify a turning point. This is a turning point, and we have two turning points here. And what we're going to do, we're going to divide the sections by turning point. So let's just assume that the graph is going with the arrow. So we have two sections. Section 1 section 2, in between the turning point, and section 3. Okay. Now, as you can see for section 1, the graph, when you're reading a graph, you're always reading from left to right, like as you would read a book. As I move left to right, what's happening to my slope or my y value? It's increasing. So this is increasing, positive. What about 2? As I read left to right, from -2, and it's decreasing, so it's negative. And then from turning point and on, it's increasing, so therefore it's going to be positive. So interval of increase is, again, you're always writing in terms of domain. And we're going to write it in set notation. X belonging to, so it's increasing from -infinity over here, so -infinity, comma, at -2. And again, it's increasing from at when x is 0. So you use union of, so this is a symbol, union, and it's 0 to infinity. That's intervals of increase. Now, intervals of decrease is section number 2. So it's decreasing from when x is -2 to 0. So interval of decrease, x belonging to, between -2 and 0. Okay. Now, what is the difference between odd and even functions? Odd functions is when the negative input of x is equal to the original function, and they are symmetrical about the origin. So odd function, an example could be a cubic function. So how do you know? So what you can do is symmetrical through the origin means at the origin. So you're going to flip it twice. Flip it once through the y-axis and flip it through the x-axis. So flip 1 through the y-axis and flip again through the x-axis. It look like this. Back to my original. So therefore, it's symmetrical through the origin. Even function is when you have a negative input is equal to the negative of the output. So another way to represent this, usually it's negative f at -x is equal to f of x. They both mean the same. And they're symmetrical through the y-axis. The standard even function will be like a parabola. This parabola is symmetrical through the y-axis. So some functions can be odd or even or neither. So you will have to do a algebraic calculation to figure out if the odd function by putting a negative input or negative on the output. So let's classify if it's odd or even function. So the first graph, let's see. So it seems like it's symmetrical through the origin. So you flip it once, and then you flip it again. And I get the original graph. So this is a odd function, symmetrical through the origin. The second one is symmetrical through the y-axis. If I were to cut in half at the y-axis, it's exactly the mirror image. So this is a even function. Let's take a look at what's the difference between continuous and discontinuous function. In order to be continuous, you have to draw the graph without lifting the pencil from the paper. So for example, this graph, I'm tracing it, and I'm tracing it without even lifting my pencil. This one is a continuous. But on the other hand, let's say I have a reciprocal function. So I'm going left to right. So I'm going down, but I have to lift the pencil to continue on the other side. So this is discontinuous function. Now, if there are any holes or jumps or infinite breaks, they are discontinuous. So for example, a hole means there is like an empty circle, like this. This graph is discontinuous because there's a hole. And this section, there is a jump. So therefore, this is discontinuous. And infinite break means that there is a asymptote. If there's an asymptote, it's discontinuous. And behavior. So we need to know what's happening to the y values as x approaches infinity or negative infinity. So we say, when the question says write the end behavior, you say as x approaches with the arrow negative infinity, y approaches, and you could say infinity, 0, doesn't matter. Let's say infinity. Okay, so in this case, looks like this. So as x approaches infinity, as I go this way, y is going to keep increasing, right? And then as x approaches positive infinity, what's happening? As x increases, y is going to go down. So y approaches negative infinity. Okay, so this is a standard statement that you have to make for end behavior. So let's take a look at the end behavior of this function, assuming that there's an arrow. So we say as x approaches negative infinity, what's happening to my y? So it looks like we have, I know it's touching, but technically it's approaching 2. Do you see that? So there is a asymptote. So y is approaching 2. Okay. And then as x approaches positive infinity, y is going to keep going down. So y approaches negative infinity. Describe the properties of f at x, and we have a cubic function. So let's write the domain and range. At first, I would draw a rough diagram of cubic function. So domain x can be any real number, right? As you go left or right, it's touching all the x. Range, y can be any real number. And as you can see, the y is going to keep going up and down. And that's it. No restriction. Intervals of increase and decrease. In order to do that, find the turning point. But as you can see in this graph, there's no vertex. There's no turning point. So therefore, there are none. Are there any maximum or minimum points? No, there's none because we don't have any turning point, meaning there's no vertex. Okay, let's draw this. Okay. Now, is this graph an odd or even or neither? Well, as you can see, it's symmetrical through the the origin. So therefore, it's a odd function. Another algebraic way to do it is, let's figure the input. Let's input negative x and see what you get. So negative x cubic is negative 3. So as you can see, f at negative x does not equal to f at x. Well, let's see. Let's plug in negative to the whole function. So then negative x cubic is equal to negative becomes positive. So it's x cubic. So therefore, we can say that negative f at negative x is equal to my original function. So therefore, it's an odd function. And then, is this continuous or discontinuous? It's continuous. I can draw the graph without lifting my pencil. And the end behavior. As x approaches negative infinity, y, it's going to keep going down. So y approaches negative infinity. As x approaches positive infinity, so as you can see, the y value is going to keep going up. So y approaches positive infinity.